Hello, hello. That's a better crowd than I expected. Thanks very much. Thanks for staying around this late in the afternoon. I'm Oliver. A little bit about myself. Three things about myself which are important about this talk is I used to be an industrial engineer that did operations research in the early 90s. Wrote a master's thesis on the topic of neural networks in combinatorial optimization, and especially on the topic of machine scheduling. And after that, during a short blip when neural networks were kind of like a hype topic in the 90s, then I moved to the US. Just around the time when the internet started, and I decided to switch sides from working inside the company to thinking about how markets work, especially how markets will be changed by the upcoming internet. Is this working better? Okay. So I did my PhD on putting the network in network externalities, and I went back into industry, went back to Germany. Forgot about economics for a while, and then sort of like the cryptoeconomics boom started, and which really sort of brought me back into seeing that like a lot of the questions that the emerging internet era, the attention economy asks, have not been really addressed properly by economics as it is, and cryptoeconomics is really sort of like for me, the starting point to ask very, very fundamental questions about how the economy works. And sort of I start a little bit of a program, and this is for me a bit of a kickoff in a way of like trying to understand how things changed since the mid-90s and how we could use cryptography, cryptoeconomics to get things right. And this is like the first talk. It will be 90% economics, 10% cryptoeconomics, just as a warning. The other thing is it will be not a math talk. I was trying to keep it on a very conceptual level. So I hope to get everyone on board. It's not only for the techies and the math people. So I'm trying to talk a little bit about two things. Is sort of what are the fundamental questions cryptoeconomics and the crypto world asks of economics and on the economy. And then for me, the second thing is sort of like how can I extract the things I learned from this and sort of write a little bit of a setup, a framework of like very, very fundamental building blocks to understand how the economy works, how the economy worked over the last 25 years, and how we hope that we can change some of the things. So this is the first of the talk, as I'm expecting a couple of series. So the first one will be about how we think about space and structure within economics, and how this sort of like blocks our view of things we really need to understand about economic organization, right? So a wonderful little story by Herbert Simon, a Nobel laureate. I don't know if you know him. He was a political scientist, then he was an economist, then he was a computer scientist, was like one of the fathers of artificial intelligence, and also famous for like doing very fundamental things about economic organization. He's the inventor of bounded rationality for once. So he has like this little story, which goes like, imagine you're a visitor from Mars. You have the ability to look at Earth from space. You have a telescope, a very special telescope that doesn't show you the world as is, but it actually shows you the social structures. What are you going to see? So first thing we see bubbles, green bubbles for some reason, solid green bubbles emerging. They're firms, they're organizations. They are structures that bound people in a way. So the next thing that happens, what you usually see is you see market transactions in between those bubbles. Right? There's a little bit of a mistake. This is actually not really market transactions yet, because market means you aggregate things. Right now it's trade transactions between those bubbles. Right, and the next thing that happens, cracks appear. And this is, the cracks are the lines of authorities. This is hierarchies. And there are many, many, many types of organization, but almost all firms, almost all productive organizations tend to turn into hierarchies. And the next thing you observed is, so if the Martian was basically sending a message back home, what do we say? Like, it doesn't matter what society you're in, if it's capitalist society, if it's a market society, if it's socialist, anything else, almost all the things you see is like mostly green bubbles and very few red lines. And it's like, why is that? Like, why do people like to hide within those bubbles? And so I remember this quote when I started like thinking about cryptoeconomics. Is really sort of like the goal. Cryptoeconomics is, in my way, in my interpretation, to flip this around, to think more about red lines, sorry, and shrink those green bubbles. We don't like hierarchical organizations so much. We're looking for participatory ways of organizing, and we're looking for ways to protect those red lines so they're not getting sucked into the green bubbles. So this is my starting point to think about this. There's one thing missing. Anyone notice something that was missing so far? The cracks. There were a couple more cracks missing. I was getting too lazy. Yeah. No. Looking at like this, one of my most famous quotes within the economy of the post-World War is Friedrich Hayek's claim that we need decentralization to ensure that knowledge basically drives production, right? So we have to make sure that the people who know things about what's going on in these points are the people that actually make the decisions. So what's missing really here in Simon's world is flow. Right? So we're not, Simon's world is very static. So, and one of the things cryptoeconomics started to do is like talk about disintermediation, meaning that we have a complete graph between all those bubbles, which most likely will not work out. This is a really simple thing that you have if you have multiple steps between you and the receiver. Usually, there will be multiple parties taken over. So basically, the question we have to ask ourselves is a question of what I call value chain integrity. And there's two things to look at this. This is basically, the key question is, like, if you have a flow from its origin, it's a transaction flow or a goods flow, information flow, whatever we are moving around within the economy, does everyone within this flow get the return that reflects their contribution? And I could go, like this problem can go in two directions. And this is like, okay, you have someone in the middle, and this is very common in supply chains, that you have only one bubble extracting all the rents, all the returns from this process. This is like the middleman problem usually. Or the other way around is, so you basically, you introduce spoilage within this value chain, and you're only at the very end of the value chain. You notice something went wrong within this value chain, and you cannot figure out who introduced this problem into the chain. And this is like why the big thing that cryptoeconomics did is really flip around the audit trail. The audit trail we had so far, this was the green bubble audit trail. This is common corporate accounting, which is basically creates this bubble. It basically creates a boundary. So this is everything is within the organization. This is accounted for. Everything that happens in between, we don't know, which means we cannot really say. what happens here to here to here to here, we're losing connections. And this is sort of really one of the biggest contributions of Satoshi by offering this shared audit trail that we can actually start thinking about how to trace these problems. So this is my interpretation of what are the key contributions of the crypto world to economics. So we really started looking at things from the opposite directions. We're no longer thinking about bubbles, the green bubbles that are protected from the outside world. They are hierarchical, they're bounded, and they're kind of accountable, which is a problem. But we can actually think about how can we protect this red network and how can we set up a network world rather than a hierarchical world. So this is the two questions we have to ask ourselves. The problem is like we're not going to get rid of the green blobs. We just try to make sure that individual green blobs cannot take over the whole value creation or get all returns on value creation. So, and the other thing is, of course, there's a more technical question: how do we protect, using cryptography, the integrity of the value chain, the red light value chain? So. So the problem is economics as it is. I'm not sure, like, assuming everyone has ever taken at least one economics class, so we know, like, supply and demand, so I don't have to go into this detail. Economics has a very, very particular conception of space and structure. Sorry, yeah. Economics has a very particular conception of space and structure, and this is like, conceptualizing space is very intuitive. Once you think about certain things in a certain spatial ways, it's very, very hard to snap out of it, and I think this is like probably the much better crowd to talk about those things. So this creates problems. So let's have a look at how we think of choice space within economics. It's not like with the very simple things. You have binary choices between bread and potatoes or other things. We have that in other fields too, in technology. Famous example from the 1980s. Are you going to use a VHS video recorder or a beta video recorder that was used in the early papers on network externalities? Ergonomics, also a technology topic. Are you going to use the QWERTY keyboard or are you going to use the Dvorak keyboard? Also used in politics. So are you progressive or liberal or are you conservative? So this is like the most simple way to think about choice. Too simple, and someone came up, okay, it's actually, this is a false dichotomy, it's a false binary. There's actually a line, there's moderate people in between, right? And so we can actually have distribution of people's political views over this line, right? So the distribution of progressives and a distribution of conservatives. So you have a one-dimensional line, and we can continue this going into multiple dimensions, right? So we have a conservative bubble, progressive bubble. A couple of fewer people are like libertarian or authoritarians, and we can continue this from the two-dimensional space. This is like undergrad economics. If you ever take an undergrad economics class, you know everything happens in a two-dimensional space. And if you go to the PhD level, we go into the n-dimensional space. And we're looking for ways to separate this n-dimensional space into cut hyperplanes. So we're trying to cut through this space with a line, with a budget line or similar things, right? So really, it's getting mathematically much more complicated, but in the end, we're still doing the same thing. We're just moving into higher dimensional space. But I was trying to look for a good example to show how this conceptualization of space loses you information and loses you critical information at the wrong point in time. So There's this a famous paper by Philip Converse about belief systems of mass publics. And like one of the things he says, it's a little bit paraphrased here, is that the belief systems are the knowledge of what goes with what. And this is sort of like information we're dropping when we put everything in a space from the get-go. And this is sort of the information I want to bring out again by using combinatorics, and combinatorics translated means networks, right? So like you're talking about this one type of network with a hierarchy, which is a search tree, and the other type of network, which is a decentralized model of network, and we want to find out how we can model this. So now we're in the world of combinatorial optimization. There are a lot of operations research problems that are being done with combinatorial optimization. It usually means that you start with discrete choices you have, and you compiling information not only on what goes with what, but also what goes afterwards, what has to go together. Famous examples is with Königsberg bridge systems. Can you come up with a road through 7 bridges in Königsberg? These are the problems. So machine scheduling is one. Matching assignment, process and contracts, which is, of course, of interest to cryptoeconomics. Things that go after each other are always interesting to combinatorics. Routing problems, branch and bound problems, search tree problems are combinatorial. And then that's where we're starting to get interested. We can talk about network structure and network boundaries. So we can actually go away from thinking like Herb Simon did, that every transaction is a market, to there's a network of transactions, and if we aggregate them, they turn into a market. So the other thing is, the last thing is something I did, is coordinate choice influence. And the thing is, if you take any of these mostly solved operations research problems we have here, and you add coordinated in front of them. So what is coordinated machine replacement? Another word for that is innovation, right? It's basically, it's easy for Vitalik if he wants to decide he wants to, whatever, replace his laptop. But if you're replacing your laptop influences you for some reason, or whatever, switching from one messaging client to another, which is like the typical example, right? So like you're losing connections. This is the type of things we're considering. This is sort of why combinatorics is really the right tool of thinking about how to solve coordination problems, right? Everything else, matching assignment, Uber, this is all Uber and Tinder problems. Search and routing is, of course, Uber too. Where do you want? A market is not all the cars, all the Uber cars in San Francisco. A market is you want to go from the Mission to Castro at Friday afternoon, right? This is your market. You're only interested in the cars that are willing to bring you there. On the other hand, only the drivers. So this is like all questions where we start thinking of a market not as an aggregated thing, but a network of transactions. So this is the tool that helps us. What's happening in economics now? If you want to design an economic model, you go through a couple steps usually. You have a real-world problem that's fairly complicated. You want to simplify this. You choose your vector space. Everybody has the same vector space. Then you make some behavioral assumptions. The typical is, of course, a rational actor assumption, but you can actually change that a lot. And you choose resolution criteria, which usually means a Nash equilibrium or any kind of equilibrium criterion, right? This economics gets criticized a lot on those two things, that we're thinking too much about rational actors, and we're thinking too much about equilibria. But it's really the thing, and then it's like the last thing is you bring in a special circumstance that make your model publisher. Right? You see it as a bubble missing, and that was the what goes with what bubble. We're sort of ignoring the special space and structure we're in. And then only if we do that, we can make a decision if it makes sense to go into a Euclidean vector space, like the normal space we think, or we skip this step completely and basically try to model economics within a network. Okay, I assume this was a little bit too abstract now, so let's try an example. I picked an example that's probably on almost everyone's minds, which is like going right now. This is basically the American political situation, which is very much in turmoil right now. And we said, okay, we have a starting point is our one-dimensional policy line, which is used in almost all publications, from liberal to conservative. But we can actually take this apart. And the interesting thing is about this is not that this exists, but it's actually one-dimensional, right? The interesting thing is that if you look at very, very different issues, we're looking at abortion, gun rights, free speech, or other things like more local things, people who have a progressive opinion, and like these are all individual issues, people who have a progressive opinion on something will most likely have progressive opinions on very, very unrelated things. This is the what goes with what, right? How does the same thing, conservatives tend to be conservative all across the board, all kinds of issues, and then we have the moderates in between. And the thing is, like, what is happening here in the middle? And there could be two explanations. One is, sorry, this is like what's happening in the middle. So there could be two things. Moderates could just have like weak preferences between the two, or they could be inconsistent, right? They have progressive opinions on one issue, conservative opinions on the other issue. So they're really mixed in the middle, and they're inconsistent about their beliefs or their ideology. And this is sort of very critical because we are sort of facing a situation that American electoral politics gets more and more polarized. And this might offer an answer to this, because if, like, say, if I'm a progressive, I'm going to agree with this guy across the board, mostly. If I'm conservative, I'm going to agree with this guy across the board. If I'm moderate, I might actually be progressive on this one, conservative on this one, progressive. So I might actually not be basically in agreement with the other person, right, the other moderate. So we're actually sort of, people are progressive, share the same beliefs. People who are conservative share the same beliefs. People who are in the middle can be across the board. And so this could explain why electoral politics in the U.S. drives towards the polarizations, right? So something I did, so you can see it's like a very old JPEG. It's from 2000 something. In like a couple of hours for a term paper on a political science class, I was looking at how the U.S. Senate was voting in early 60s, and you see like, okay, here's, this is actually from progressive to conservative here. So if you have progressive senators tended to vote with each other, then we have a middle, and then we have a couple of conservatives, Republican senators voting in the middle. You see a couple of stripes here. This is like the Southern Democrats. But you have some sort of kind of continuity, right? So, and then so I did the same thing for the Senate back then, and suddenly you have very polarized voting. And it's like, at this point, like everybody assumed, all the political science world really assumed, okay, we're still in this world. In comparison to like the early 1900s, voting was not very polarized. There was a lot of coalition formations between the two voting blocks. That's what everybody assumed. And so this is like the first inkling that there was actually something going on which we didn't quite understand, right? The question is here, how can we see this? If we're moving this into a a unidimensional world, just one policy line, and I'm going to use, so I forgot to source this, so I posted this on Twitter. It's a paper from 2015 that sort of did the same thing a couple of years later, and you see sort of, they're kind of splitting up eventually, but it comes out fairly late, right? It's still 99 is still sort of starting here. Okay, this is actually starting to separate the two parties are starting to separate. So they did the same thing with kind of a network, and realized that you're starting the separation becomes clearer much earlier. Right. So this is the one thing we see if you're going from the one-dimensional space to, well, what looks like a network. Right? But it's really a two-dimensional representation. So they basically decided we're not going to look at one dimension, we're going to look at two dimensions. It's getting more obvious. What is missing here? And this is the crucial thing. This is like sort of the thing you have to understand about American politics, that American politics is mostly unidimensional. In most of the cases, most of the times, they're mixed, but in sort of, you can still tell what is progressive, what is conservative for most votes. But in times of crisis, there's a second dimension emerging. Right? And there's something, if you decide beforehand that you're looking at things in a unidimensional way or in a two-dimensional way, if you're pressing a network into two dimensions, you're losing this information. And what is happening when a second dimension emerges is that parties split up. Right? And this is exactly what we're seeing. They're not splitting up in sort of like the major ideological way. They're actually splitting up on issues that cannot be captured from progressives. There's completely new, usually new things create new tensions. And this is sort of, if we can do this, we can actually model on real data this economic organization which I showed earlier, basically the bubbles and the lines. As you can see here, there's blue bubbles and red bubbles in this case here. And we can separate them. We can actually answer the questions like how many dimensions do we see? What drives this separation? You're basically watching right now sort of like the Democratic Party splitting in two. We kind of watched the Republicans split in two after Mitt Romney lost his presidential election. And then sort of like what used to be the Tea Party is basically taken over the whole Republican Party, and it shed its moderate wing, and sort of now the Democrats have the situation where they have the socialists and the moderates and sort of the former Republicans, and they have to find a way to bring them all under one umbrella. This is sort of really what creates the tension in here. And this is something you miss out on if you start looking at things on the Euclidean vector space, because you're dropping information at this point, right? Little side note, this is something also, most of the empirical work on politics used to use issue scores based on voting behavior published by think tanks. Usually you have a liberal think tank. They want to spread out the Democratic caucus. They want to say, okay, this is the whatever the legislator is closest to us, and this is the one that's further away. And they also want to like press the other party all in the extreme corner. Right? So on the other hand, there's also conservative think tanks that do the same thing. And then you suddenly have the situation that you have conflicting spaces. And this is something called perspective bias, that you have this tendency to see things that are closer to you, more spread out, more pronounced than the things that are further away from you. And this is sort of part of the most important tool to analyze what's going on in politics right now. So if you're, say, you're moderate, you're sort of, okay, I'd like to vote Joe Biden. I think Sanders is too extreme for me. But if Biden loses, I vote for Sanders, but I hope the people who are supporting Sanders do the same. And I basically hear, okay, Sanders people say, oh, no, like Biden and Trump, they're basically the same, they're interchangeable. So this is really a perspective thing, right? So people tend to shrink things that are further away, and this is sort of really happens in our perception. If you drop this, if you sort of move right into a Euclidean space to model your scenario, this is something you miss out on. This is sort of why you can use networks and why you use combinatorics to understand what's going on here. So as I said, ideology, politics tends to be unidimensional. Almost all other preferences space, if it's music or films or something, are usually very complex, very high dimensional. This has sort of created this whole industry of recommender systems, from Amazon to Netflix, everyone who's basically trying to figure out, Spotify, everyone who's trying to figure out what is, if you like something, what are the other things in that neighborhood that you might like too? Right? This is very important for them to always feed you with new things and have a high probability to solve this. And it's the interesting thing enough is like I've been watching this industry for 20 years, and it's really sort of this is the ones that end up using mostly neural networks because sort of like spatial economic regression models didn't really help them. Turns out they're using very complex mixes between the two. But this is sort of the problems you have when you start with a choice model. And I don't know what the time is. Can you wrap up quickly? So I run through a couple of...
6 minutes.
Okay, good. So I run through a couple of other examples quickly. So every paper on this technology standards discussion was discussing the QWERTY keyboard, which everybody uses, versus this alternative keyboard called the Dvorak keyboard. But how does the space look like? What is in between? Turns out if you're just using the 26 letter keys, there's like 400 septillion or something ways to place those 26 keys on these 3 lines of the keyboard. All right, so why did we end up with mostly this? There's about 20 keyboard designs used worldwide. About 10 are variations of QWERTY. The other 10 are alternatives. How did we end up with those 20 out of this situation? And you can say, okay, like that's a lot of keys, but well, the line has infinite points, right? So it's actually easier. But you cannot just simply go from here to here and say, okay, what does it mean shifting on this line from here to here? So how do you resolve that? It's 2 ways. So you basically you do combinations. You're flipping keys around. And you're always interested, there's a couple of ergonomic criteria how this should work. So basically not using the pinky finger for frequently used keys, switching hands left and right. So you can measure performance now, and but basically you have to flip out. And this is the problem, that you cannot just go along the line and do marginal analysis to find the peak points. You have to actually switch. Or the other famous example is the Schelling segregation game, which is also a way to switching to reduce friction in the system, which in this case is basically the performance criteria. So if you take this typical economic definition of technology, it transfers the famous factor in plus labor, capital, and soil into products. So it's just a production function. But if you change that definition to what we've just seen, it's a combination of features that need to work in conjunction, and most of those conjunctions, most of the combinations just simply don't work. So you have to pick out the ones that actually work. Then we are actually in the combinatorial world. Once you're there, almost everything turns into a technology. Language is a technology. It's basically you can take a word, you can switch out letters. This is like Hamming distance or something. It's still comprehensible. This happened over, I don't know, when in the European came around, like 3,000 before Christ or something. So 5,000 years. A lot of single switchings to the point that so many languages started to emerge that are now mutually incomprehensible. So this is like really a long-term switching process. We see this over and over again. There's also a refutation of this idea that because you have positive network externalities, and languages have positive network externalities, I hope I can communicate with you right now because we speak the same language, even if it's our second language. Still, you have this conflict between common shared interest of communicating and individual preference. And individual preferences usually come from the way people's thought boxes are shaped, right? So this is where dialects come from. Right, so you have these mechanisms, and you can actually use this for almost anything. Once we're talking about this, this is a technology, a market is a technology, because a market is anything, and it's like talking Uber, you're no longer talking about ride sharing, you're talking about going from this spot to this spot at this point in time, and this is only the other interesting people in the same spot are your markets. So you have a lot of combinations, and this is why those matchmaking platforms emerged, because this is a computationally hard problem, right? And this is basically a key problem economics has, because a market should be a market, and a market should not be an enterprise. Where we now, economics as it is, post-war economics, emerged to solve production problems. And this is sort of, right now, it's still doing fine in this area. We have two other problems. This is typical production function, so this is we're decreasing returns to your input start. Two other problems we have, this is the one that's most important in cryptoeconomics, is the problem of governance. This is when you have, when you're in a situation that you have many inputs, and you have to share them equitably. This is where you need combinatorial. And the other one is at the lower end. And this is just like the second part of a startup hockey stick here, right? This is an entrepreneurship when you have so many combinations of things you could possibly do, but only a few of those combinations work. And the only way to solve this is trial and error, or combinatorial and evolutionary. And we can continue this. Production, if you disaggregate production into supply chains, you're in a combinatorial world. Markets, as I said, any kind of matchmaking market is a combinatorial problem. So we're actually moving. The big thing that happened is a massive amount of data coming out of Silicon Valley that showed that things are not quite the way economists assumed. And this is sort of why we're in this process now.
Questions?
Hey, this was awesome. Maybe an abstract question as well to this. Like, I really liked how you approached that. You can see these problems combinatorial, and then like by iterating through all the combinations, we find that. But isn't there like a line where we can say, like, in the same way as we know, like all in numbers, we know like there's much more numbers that we cannot iterate, right?
Yeah.
All the numbers that we can iterate is actually the smallest set. So is it also true that there's problems that we cannot solve combinatorial, where it's the end, and the next step is actually something we cannot permutate anymore? Like all the irrational numbers. Like if I think of you said like my favorite rock music is probably Ndimensional.
Exactly. Yeah.
I'm thinking more of it like a irrational number. At least that's what I hope for. And if it's an irrational number, you don't get there with combinatorics, right? Is that maybe the reason why people use neural networks, because they just don't have a clue? Is that?
Well, neural networks, the reason is because it's a very complex search space. And basically, by deciding you're doing things combinatorial, you're basically structuring the search space in a way you can actually go through it. This is what's called the branch and bound algorithm. So, and a coordinated branch and bound where you have a group of people trying to go through a labyrinth together. It's like usually the set of a lot of horror stories, right? Because you not only have to decide individually, am I going this branch or I'm going this branch, you basically have to agree on which branch to go, which makes it a very, very, very complicated problem. This is why we try to use neural networks, like try to do anything we can. This is why like Uber uses massive computational capacities to solve these problems, right? So now, I said, like economics, the way we phrased it in the 50s really still solves production problems, works well. But now we're sort of in a situation that we are trying to solve market problems, which are actually much, much more complicated than we thought they were. So, and this is like the starting point is, okay, there is of course, the thing that we have real, irrational, any kind of numbers, but there's still a structure. That's like, okay, step up of complication. This is why I always try to simplify your real world into a model that you can work with. Right? So it's like basically simplifying this world into discrete steps so you can capture the structure is better in this case than using the old one. And there's like one anecdote. George Stigler, a famous Chicago economist, he was charged during World War II to find the lowest cost combination of food that would nourish people with like whatever vitamins and whatever. And so he came up and he invented linear optimization in a way doing this. And he came up with like a really low number. And it was like, and it created a huge spat with the food scientists who basically said like, okay, you cannot do this and this together. It doesn't work, right? So people are like, okay, they're getting vitamin C and whatever else, but they're not really getting fed. And Stigler was who cares? They just want to basically ramp up the price. And this is sort of kind of where I started, right? So we're ignoring the structure, getting the advantage of being able to use real numbers, using Euclidean space, and that worked for 80 years of roughly. So we're really pushing this boundary now that it's no longer really working for us to model the economy.
So how do you decide how to, like break this space? How do you categorize? At some point you need to do sampling and, how many baskets you will have, because you can go to, I guess, like totally different conclusions based on, how many options do you have.
This is the point I was trying to make with the politics example. You can, during normal time, the normal way with a policy, the one-dimensional policy line, explains almost everything. So it's really cool to use that. But if you have turmoil, then it doesn't work anymore. And this is the problem, right? So like, and this is what economics should focus on, be able to explain the turmoil. But this is a design decision. I said it was a design decision that's like 60, 80 years old. So it's really ingrained. So people don't, like economists usually don't think about that stuff anymore. But it's sort of, I did sort of within the afternoon, like trying to solve this one term paper problem. I sort of looked at, okay, what's going on? What is like, how do these things relate to each other? And this is how I came up with these matrices. And sort of started thinking, okay, how can I express this relationship between those people? Rather than,
are there some like general finding about probably there is some optimum, yes, but are there general findings about like for measuring the stuff to rather how to say merging these categories or rather splitting them? I mean, do you usually start with like few and then build up, or you usually start with many and then try to merge?
It's always good to start with the simplest model, like binary model. As long as it's binary progressive conservative model, as long as it answers the question you're asking, That's the simplest way. And I realized okay, this model is not good enough to capture the things I'm looking for.
Yeah, but isn't it that like if I start with the binary model, I can go to the wrong conclusions, and I'm just not aware about it?
Exactly. Yeah. I mean, this is what's happening.
So my impression.
This is like you can tell when political candidates have the wrong consultants.
My impression is like I would start with, I don't know, based on some assumptions. Yes, that like to have many options and then try to merge them.
Okay. I think people want to leave, so we can have this conversation. Sadly, I did a podcast, but sadly in German, explaining why Nate Silver got the Trump election wrong, because he was using a model, a mental model of politics, which was really based on a spatial line that worked for a long time, and it created a lot of successes for him. And I didn't realize what was going on between the second Obama presidency and the Trump election. And so he did not change his political model. Of course, he did changed his polling model, but this is a very, very different question. So once you start realizing the model you're running does not answer you the questions anymore, you have to start refining your model. And sometimes you're not refining your model, you have to switch domain. In this case, it would be like to go from the marginal domain to the combinatorial domain, because it really answers you a very, very different kind of question. It's the question of what goes with what, or who goes with who goes after who, what goes after what. So basically everything you're thinking of in terms of coordination, which is a very big topic in cryptoeconomics, you should start really thinking from a combinatorial perspective. And that means networks, really. So, thank you. Are we done? Or? Yeah. So, thank you very much.